Hello everyone, welcome to my presentation on deep learning. In the next few minutes, we will embark on a journey through the fascinating world of artificial intelligence, exploring how deep learning in particular has become a driving force in its revolution. We will dive into the intricacies of neural networks, understand how they mimic the human brain, and see how they're revolutionizing industries in our daily lives. To start off, what is deep learning? Before we jump into the description of what deep learning is, I will give you a premise so it will be easier for you to grasp the description later on. Okay, so basically, deep learning powers most of the technologies that we rely on every single day. This could be facial recognition that we use to log into our phones, or it could be recommendations that we rely on to show us the next best TV show. It could be, for example, on Netflix. Moving on to the description, deep learning is a group of techniques that are based on neural networks that have the capacity to learn complex patterns directly from the data. So I have mentioned neural networks quite a few times already, and that is because it is a crucial and prominent aspect that makes up the concept of deep learning. Okay, so what are neural networks that I had mentioned before that were so crucial? So I have provided a description here, but to put it in short, neural networks are a type of machine learning algorithm that was created inspired by the human brain. So in this diagram over here, you will notice that we have layers of neurons stacked one after the other. In neural networks, we have three different types of networks. First is the input layer, where we accept the input. The second layer is called the hidden layer, where basically the math happens in the neural networks. The third and final layer is the output layer at the end of the networks. It gives the actual prediction, outcome prediction, or the output of the network. All of these layers consist of neurons. There is always one input layer and one output layer. And the more hidden layers that you have in between the input and output layer, the deeper the network that you are going to have. So this is where the keyword deep comes from in deep learning. And the learning part comes from the machine learning, or the fact that the network is able to learn different complex patterns. Now, how does the concept of machine learning compare to deep learning? I had mentioned before that neural networks are a type of machine learning algorithm. Well, let us take a step back and observe the broad picture. We know that the umbrella of computer science is very broad, and many different branches could come under it, like computer security and software engineering, and one of these many branches is called, you guessed it, artificial intelligence. Deep learning is a subset of machine learning. So when we talk about machine learning, we're actually including deep learning as well. However, when we want to compare machine learning versus deep learning, of course, we are trying to compare the traditional machine learning algorithm versus deep learning algorithm. The first and most prominent difference is that when you're training machine learning algorithms, you need features extracted from data manually. For example, you as an individual have to extract the data yourself and feed it into your data. And when you are doing deep learning training, you don't have to do that, which brings us to the advantages of deep learning. Okay, so I have listed out a few advantages here, but let's just say that you're trying to classify cats versus dogs, which is the most common example on the internet, by the way. Moving on. What happens when you're trying to train your model to understand if a given picture is of a cat or a dog? So for machine learning, you have to extract features such as how many pointy ears it has, or the shape and color of its nose, and the posture they're resting in. But for deep learning, you can give the image as is to your deep learning algorithm, and it will itself understand what the pattern is and what the features are that are separating these two animals from each other. So basically, what I'm trying to say is for machine learning, you as an individual have to manually extract the data of the features and feed it to your algorithm so it will be able to identify which animal is which. But for deep learning, you don't have to do that. You feed this image to your algorithm, and it will itself be able to decipher those features and identify which is which. There was one more difference that I did not mention before, because it is a major advantage as well, which is the reason why I am mentioning it right now. The difference is that deep learning algorithms are actually able to capture patterns a little bit more abstractly. You will get that confusing right now, but in the next slide it will be quite clear. So you can actually perform tasks with deep learning algorithms that would not be able to do with traditional machine learning algorithms. Okay, so this is the abstract pattern I was talking about in the previous slide, which brings us to the real world applications. The first one is medical diagnosis. We just use this AI to solve one of the most important yet unsolved issues of modern science. The issue that we are referring to is trying to predict a 3D structure of a protein using just its amino acids building blocks, which are these structures right here. Being able to do this is a big deal for creating new medicine. We have already used this technology to create treatment for diabetes, sickle cell disease, and even breast cancer, and the list goes on. It is very hard to overstate how big of a deal this is. The new ways how we can figure out how to help people with this knowledge explosion. Here are a few more real world applications which include autonomous cars. I'm pretty sure by now everyone here has either seen or heard about self driving cabs. And another application is robotics. Finally, in conclusion, before I end, we determined that deep learning is revolutionizing artificial intelligence and is introducing significant discoveries which will affect a vast majority of industries. And that concludes my presentation about deep learning. Thank you.